Okay,
Would you
very
like me
good.
to introduce you?
Yes.
Please welcome Professor Ariel Cintron-Arias, who's going to talk today on asynchronous online courses.
Thank you. Thank you, Rick. So thank you for the opportunity. I have the pleasure to have an audience here in Lamb Hall, and then I have a few people also attending by Webex. And for those of you that don't know me, I first would like to introduce my collaborators in this effort, Ryan Evans, Michael Garrett, Jonathan Hicks, and Rodney Keaton. I am professor in the department, an associate professor in the Department of Mathematics and Statistics. My PhD is in applied mathematics, and I have 9 years of experience at higher education instruction. I first taught an online class in 2015, and the first online class that I developed was an asynchronous online class that was graduate only and online only. And in the summer of 2018, I completed the development of 3 asynchronous online classes that were undergraduate curriculum, and that's part of the motivation of what I intend to share with you today. So I'd like to start by maybe illustrating a day in the life, and you may wonder, day in the life of who? Well, as you start seeing these images here, I think that you would agree with me that this isn't the day in the life for basically anybody, right? So mobile devices such as smartphones and tablets and laptop computers are things that are part of everyday's life for many of us. I would dare to guess that if you are not, it's very likely that all of us are within 1 degree of separation of somebody that their smartphone is the last thing they see before they go to bed, before they fall asleep, and their smartphone is the first thing they see when they wake up, in part because smartphone is the alarm clock in a way. So I have plenty of students in my mathematics courses that are gamers, and computer games is something that has evolved from the old days of Atari and Pac-Man and consoles and things of that into playing computer games live. And when that happens, the gamers are simultaneously playing in very distant locations. They usually wear a headset with a microphone and headphones, and they are partnering up. They have either partners or opponents that are playing simultaneously live with them. And so another thing of day-to-day modern communication is the way we are placing phone calls right now, that we have the ability to also have a conference call with multiple participants and also have a video, an instantaneous video. And of course, one thing that is a signature of certainly these things evolve so fast in time that all the digital social media, the way they are today, is vastly different than what they were 5, 10, or even 15 years ago. But even in 5 years, you can notice remarkable differences between something like Facebook or LinkedIn. So in mathematics instruction, student engagement and student participation, I think, are key factors of instruction. This is independent of whether instruction is distance learning or on ground or in person. And so I think that it's possible to integrate some of these modern telecommunications with the instruction of mathematics. I use here the term advanced mathematics. Maybe it would be more precise to say moderate to advanced. Certainly I'm referring to 3 classes that are not upper level, because here at ETSU upper level means 3,000 or 4,000, and Calculus 2, linear algebra and differential equation are 1,000 and 2,000. But the entry point for those classes is Calculus 1, so they're not elementary mathematics. Okay, so a few examples of how some of these very standard for students way of communicating on day-to-day life, which could be easily integrated on instruction of mathematics, include students typing on a live chat, students participating on video calls, students, small size groups of students contributing to blogs that have a specific theme, and the usual email communications where I think this is a very standard way which each instructor right now communicates either with the entire class or with one student at a time. So My own vision of how to deliver content for an asynchronous online class is something that relies on basically 3 steps or 3 ingredients. And this is borrowing, this is a colleague of mine explained this to me basically in 3 words, and I think it's a great way of explaining it. So steps or the ingredients of this recipe are read, watch, and practice. And so you could think of these as things that are linear. I like to think of them more in a cycle fashion. So you could read first, watch second, and realize you need to go back and read some more. And then after reading and watching and reading some more, then you go into the practice. And while you're practicing, you realize you have to watch again and read some more and then do some more practice, right? So I think that this is something more in a cyclic fashion. And so as far as the practice goes, this involves assessment at 2 levels, a low-level assessment and high-level assessment. And this is a part in which my collaborators are kind of helping me in terms of phrasing these kind of things in terms of something they call Bloom's taxonomy and some other theories of learning that are pertinent. I'm not so well versed in those theories yet, but I can tell you that part of the practice involves questions that are automatically graded, which are formative in nature, and then questions that are manually graded, which are both formative and summative types of assessments. So I mentioned something about a day in the life of anybody, and here I have an illustration that is a week in the life of a student in one of these asynchronous online classes that I have designed. And so typically a 3-credit-hour class would have an expectation of requiring 9 to 10 hours of work per week. A 4-credit-hour class would have an expectation of requiring 12 hours of work per week. And so the illustration I have here is, I have to admit, a little bit extreme in the sense that this is illustrating how to budget the time over 7 days a week. What you see at the bottom there is one way of distributing 12 hours and allocating this number of hours. The important thing is that structured in this way, students have due items 4 days. There are items that are due Wednesday, Thursday, Friday, and Saturday. On Wednesday, there is the items that are considered low-level assessments. That's when they are due. And the other high-level assessments, because my approach here is instead of having everything due one day of the week on Friday or Saturday, I segment or break that up into smaller pieces. This is also an attempt to assist or guide students into, you need to get to work as early as possible. Even though these things are due on specific days of the week, they could be submitted at any given time. So while my approach here, by providing this illustration, is a little extreme in the sense of you should be working 7 days a week, the student has a choice of maybe getting the work done in 4 days a week or 3 days a week. Certainly, with this I'm signaling, I do not recommend that you as a student do the work 1 day a week. In part, and the reason why this structure and having items collected on Wednesday, Thursday, and Friday, in part because the work here is what you're trying is you need to assimilate, you need some time to digest certain things, and this is an approach that is a building block kind of scheme on foundations, right? And so getting all the work done 1 day a week is probably not something that's going to help you too much. The other thing to notice is that there are some items that are due on Saturday, which will be some of those questions that are graded manually, and students have an opportunity to submit an early draft on Wednesday or Thursday of their work on progress, and by Friday, I can provide them with some general guidelines and some general feedback, and they could revise what they've done and submit a final version on Saturday. So, yeah, would you please?
I'm sorry, can you fill me in on the...
Would you please press the microphone? There's a red light.
Sorry, can you fill me on the abbreviations? PE, OC, and there was a third one.
Yeah, they are not too important for what I'm conveying here. There are a lot of abbreviations because this is a thing that I have from my syllabus. I'll be happy to share my syllabus with you. But the PE means portfolio exercise. I'll explain more that in detail. That is the manually graded question. OP means online practice. Those are the automatically graded questions. KC means knowledge check. Those are the low-level assessments. So the knowledge checks, I guess it's another word for quiz, but the idea with that is due on Wednesday, of being low-level, should be very simple questions. One or two, very succinct. The way I have found, vendors or something that provide an access code with these question banks is a way in which there are questions that are actually called tutorials. And the tutorials offer the student the opportunity before answering the question to pull or generate. It's like maybe artificial intelligence-based kind of scheme. They can generate another version of the same question, and they can display not only the answer key, but also like step-by-step explanation of that type of question. They could practice that question with solutions before they actually submit an answer for that knowledge check, which is meant to be a low-level assessment. So yeah, there is a lot of abbreviations here that are kind of distracting. But
so the OP and the KC are automatically machine graded, and you personally grade the third one.
The third one, the one that is due on Saturday. So right. So this is, and I'll get to more how this structure came up. But yeah, so the structure is automatically graded stuff is due on Wednesday, Thursday, and Friday. Manually graded questions are due on Saturday. If you have the incentive as a student, if you submit early your work in progress of the stuff that is written by hand, if you submit something on Thursday and Friday, I'll take a quick look and I'll give you some pointers, before you prepare and submit your final version. Definitely after you submit, you're going to get some feedback, okay? So in developing these three classes, I was in charge of producing, or at least my vision is that the classes should have original materials. I think, as I mentioned there with the three ingredients of the recipe, read, watch, and practice. The watch part is based, I think it must be based on at least a substantial part of original videos by experienced faculty, and you could have some supplemental videos that the instructor finds. But in this case, I was in charge of producing 293 original pre-recorded videos by 4 ETSU faculty members. I also was involved with typing lecture notes in PowerPoint or LaTeX, and these also involved creating question banks in our content management system that's called Desire to Learn, or D2L. And an important part was that some of these high-level assessments are the exams, the usual exams that we have in a given semester. And I was able to coordinate the proctoring of these exams both locally and externally. And I'll give you some details about this. These three classes use technology lightly. And so I try to sometimes, even though it's very light use of technology, and these are very simple, basically like online calculators and things like that, I still have to prepare some succinct tutorials for delivering this to students that maybe are doing this for the first time. A quick look at the playlists in the official channel of ETSU on YouTube. There are 52 original videos of Calculus 2, 117 of linear algebra, and 124 in differential equations. As far as the adopted textbooks, I made a point to use textbooks that are they're part of the initiative that's sponsored by the American Institute of Mathematics. It's called the Open Textbook Initiative. And that initiative is also lined up or in agreement with a much bigger program. It's called the Open Textbook Library. So open textbook means that these textbooks are free if you download the PDF version of the book. If you want a hard copy, a paper copy, there are options for printing on demand that usually are very moderate in cost when compared to the usual textbooks of a similar nature with some of the usual publishers. Okay, so when you develop an online class, you undergo a formal process of review and evaluation here at ETSU that's performed by the Academic Technology Services Department. And in that process, there are very long set guidelines and criteria that are used to review each of these classes. And so there is a way, there's a scale in 0 to 100% of a score that is produced as an output of the evaluation. And according to that percentage obtained, then there are 4 categories. And so the top category is the category of excellent. And in this case, these 3 classes obtain a score of excellent. This would be excellence in design. Basically, this is scoring the lesson plans. This is taking a look at in theory, how you have organized the class, and it's a very competitive point of departure. Some of the things that were responsible, that were highly scored or favorite scored, responsible for earning this excellent evaluation review include the nature of having original material that is comprehensive, varied, and together with supplemental material. The assessment methods were varied, provided opportunities for students to measure the progress all along. The gradebook, it was set up. I think that this point about the gradebook is mostly making sure the students have solid knowledge of the academic standing at any given point. And another important point was something that relates to what I mentioned earlier about student engagement and student participation, so that there is a design from the start where there are opportunities for students to interact and participate with each other, and certainly for students and faculty members to also, participate or generate conversations. So that was good in terms of the theory, right? In terms of designing the lesson plans, designing the class. Now, once you implement the class, that's really when you have the reality check. That's how, that's another important part, right? So in the summer, I was a coordinator of 3 synchronous online classes, and I worked very closely with my collaborators. And we have a very interesting group. So Michael Garrett had experience teaching online classes at a graduate level, but those were education classes. Now, he had taught Calculus 2 as an on-ground class before, but he had never taught Calculus 2 as an online class. However, he had extensive experience teaching online at a different level. Then Jonathan Hicks has extensive experience teaching many, many things, but certainly, specifically a class as a general education class in mathematics. He has a lot of experience teaching this class both in person and also online, but online over a very short period of time, over 3 weeks in the winter session. And that on its own, it's a very challenging task. However, John had never taught linear algebra, neither on ground nor online, and that was his class. And I was coming in with experience of developing the 3 classes as asynchronous online classes, teaching 2 of them, and in fact having the opportunity to teach 2 of them with a diversified portfolio, meaning that I taught both differential equations and linear algebra in a way in which I had an on-ground section in Johnson City, I had a section in Kingsport, I had a video streaming section, and then I had another section that was, the pre-recorded video type of online. I had all those sections running simultaneously at the same time. So we spent many hours. We went to the library. We wrote on the board. It was very interesting, and we drafted this plan to provide students with feedback. First bullet point here, provide them office hours. Some of them will be able to come in person, but certainly in the summer we had populations that were located outside of Johnson City and outside of the state. So make sure that video conference technology was available for office hours. Supplemental instruction. I have a few things to say about this. We implemented SI with live video streaming, and then also kept an archive of recordings. And we use both automatically graded questions. Now, when you use these question banks for automatically graded questions, it's easy you're not going to use that and just give the students just one submission, because that's what you would do if you're grading manually. So the idea there is the student receives instantaneous feedback about, is this entire question incorrect, or what parts of the questions are correct and what parts are not. And then the idea is that you would give the student an opportunity to resubmit. We decided that instead of having unlimited submissions, it was more constructive to give more than one submission, but have a limited number, usually 5 or 10 submissions. And then we implemented this idea of the the manually graded questions, which we decided to call portfolio exercises. The idea inspired by the visual arts or the performing arts, where this idea of a portfolio is they have literally a binder with photographs or things of the work that they're doing. Our students here are every week working on problems, and at the very end they could print out all their worked solutions. They could put that in a binder, and that literally would be a portfolio, a mathematical portfolio of exercises. And then we decided to have Proctor examinations that had a mixture of automatically graded questions with manually graded questions that were collected as handwritten responses. Another important part of the feedback they were receiving were reports of online activity. Okay, so supplemental instruction in its original and traditional concept, basically supplemental instruction is something that relies on a peer-to-peer mentoring. So a very important component of SI is that there is an undergraduate student, which is usually dynamic or ahead of the curve, somebody that's very proficient, and this person is guiding their peers, other undergraduate students. But SI instruction could easily be implemented by a graduate assistant or a teaching assistant or the professor of the online section. Another important concept of SI is usually these are in-person meetings between small-size or medium-sized groups of students. In the summer, for us to implement this, we had to compromise because we had a group of students that were located outside of the state, and many of them were working full-time, so that even for those that were in the same location here in Johnson City, it was very tricky to have them converge at a particular time. So we compromised, and basically we had the supplemental instruction sessions function like something that's called recitation. And so the recitation was shaped in the following way. We had a leader, that's the student who was in charge of these sessions, and the leader would shape the lesson plan of the week with talking points that were provided by the instructors. So the instructor was collecting the questions that were graded manually on Saturday, and usually in 48 hours, but Monday or Tuesday, the instructor was giving back those graded questions to the students. But then at that time, Monday or Tuesday, the instructor had a clear picture of, okay, there is confusion on these things, or there is clarity on these other things. And then the instructor would pass along to the SI leader, this week, it would be worth if you review this, and so it was a mixture of the material that was the material of that week, also mixed with the material the previous week that probably needed a little more of reinforcement. Sometimes I would make suggestions to the leader to use technology in a certain way during the session because I was anticipating that they needed to see a demo or they needed to see something for the portfolio exercises of that week. So we had the great fortune to work with Mr. Mark Jones. He is completing 2 majors here at ETSU. He's majoring in mathematics and he's majoring in physics. And what you'll see here are snapshots of the conference. This technology we use here at ETSU is called Webex. There is another product called Zoom. If you've used Google Hangout or Skype, these are similar things. And you can see here on the bottom, there is Calculus 2 on the left, Linear Algebra on the right, Differential Equations. I was the coordinator of these 3 classes, and I attended most of these SI sessions. Sometimes I would attend remotely. Sometimes I would attend in person. The sessions were actually in this very same classroom here in Lamb Hall. And students were able to participate by typing on the chat window. Sometimes I would make comments. Sometimes I would ask questions. And sometimes I would help answer certain questions. And you can see, the handwriting of Mark here and different things. So how was supplemental instruction? We asked the students 2 questions, basically. How helpful were the recordings of the SI sessions? Because that was the other gain. even though it was a smaller group of students in each class that was attending live, I think the other gain was to have an archive of the recordings of these sessions. And that the talking points of these SI sessions were shaped both by what the instructors were telling the leader, you need to review that, but also the students had an opportunity to submit questions or talking points or things that they wanted to see addressed on that session, even if they know, especially if they knew they couldn't attend the session live. And then at the end, there was going to be a recording, an archive of recordings. So these are the students, sample students from Calculus 2, answering the first question where there are 5 options. So if you look at the first 3 options, this is a scale of extremely, very, somewhat, not so, not at all, helpful, okay? So if you see bars at the bottom, those are basically customers that were not so pleased, right? But if you see bars that are middle and then up, or the first 3 bars, that's at least somewhat helpful or somewhat useful. The other question was, how useful was the content of the SI sessions in improving your understanding? Okay, so what basically the Calculus 2 students here were saying is, yeah, the SI sessions were at least somewhat helpful or somewhat useful. Here's the linear algebra, the sample of linear algebra students, indicating that it was very helpful to have those recordings. There's a couple of students here that were not so pleased with how useful the SI was for their understanding, but you see sizable groups here, extremely and very helpful. And for the differential equation students, the pattern is similar. There are a couple of people here indicating that they didn't see a lot of value, but most students see at least somewhat useful or somewhat helpful the value of the SI sessions. Now, as far as the questions that are graded manually, I want to share with you an example here, a case study of a question that serves basically as, I mentioned something about a blog that is themed. Well, this is such a thing. In this question, there are certain blanks. You're going to have to forgive me because students have to actually generate 9 digits instead of 8. But there are 9 spaces here in the question that need to be filled in. So students are teamed up or paired in groups of 2. Each member of the team contributes the year of birth. So each member contributes 4 digits. Then they shuffle those digits. They choose one of those at random, generating 9 digits, and they go on and fill in the blanks of this question. So they have the choice they may use exactly the same sequence as to filling in these blanks, or even, each of them may have a different version. It's a way of creating a randomized version of the same question. And from that point on, every student is required to submit her or his answers separately, even though they have a teammate, they have a partner to compare notes. So the idea here is that throughout the week, likely, instead of copying their work, or they could copy if they want to, but the thing that's likely happening here is they're comparing notes. And they have the ability to proofread or make comments on the progress the other one is making. They also have the choice to contact the instructor directly. So for that particular question, this is an example of what student would receive. They submit early versions on Wednesday or Thursday. On Friday, there are some guidelines that are very general that are offered to everybody. Saturday, they submit their final version, and then by Monday or Tuesday, they get back something that looks like this. So in this particular case, and there is a mixture here of people that are connected in Webex and people that are here in this classroom. So I'm just gonna say this very generally. One of the things that they needed to do had to do with the order in which they did something here: U first, Y second, and they in fact were expected to do Y first, U second, and that makes a difference. This has to do with a property called commutativity, right? And so you can see here through this. This is me. These are my own handwritten notes. I'm indicating here there are certain parts that are missing. There are things that they were not done. The calculations, the procedure was correct, but it wasn't done in the right order. And so I think this is an example of providing feedback in a case in where there are several areas in need of improvement. But I also had the opportunity to let the student know about their strengths. There was a very good thing they did in which they basically compartmentalize, certain calculations. That's exactly what I would do. If I were carrying these out, I had an extra piece of paper on the side, and I would try to do this. This is something that would take 4 to 5 steps. But the fact that they break it up into, I think that's how they see it in their own mind. They're basically we're breaking that up into little blocks and obtain some value. That value was later going to be plugged into the whole enchilada calculation here, which is coming from the top. And I thought it was good to tell them that's a good practice. This, and then use this notation, divide things into little rectangles and things, because this helps you keep some cleaner, flow of what you're writing here. Mathematics, as many of you know, is a language. And when many students, they don't have to be mathematics majors, when you start reading what they write, you realize that just as any other language, there is a way in which we learn how to write mathematics. And our mathematics writing is like a fingerprint. You could really almost tell the thinking process of somebody just by looking at how they write mathematics. So some students need a little guidance in terms of polishing. Some people, the first time they submit something to you, is all over the page. It's in the upper left, on the right, lower. So when you have this opportunity of having one way of giving the feedback, and here's another thing that one of my collaborators is a master on doing. He likes to have a scheme of recovery points. He implements several iterations of the same portfolio exercise. And that's, whenever possible, that really increases, the line of communication between instructor and student. And it's something that's useful in those cases where there needs to be a cleanup or a reorder of how they're writing these mathematics. And you give somebody a few notes, let them resubmit, and you see that after second or third submission, things are coming to a different order in terms of how they write. Okay, so they were also consulted, the samples of students in Calculus 2, linear algebra, and differential equations. Hey, how about the balance here between questions that are automatically graded versus manually graded? On the top, so there are 3 possible answers here. The very last answer is, excuse me, the very top answer is, I prefer only automatically graded questions. The middle answer is, I prefer both, a little bit automatically graded, a little bit manually graded. And the last answer, which you see, there is no rectangle, there is no bar. The last answer is, oh no, I want to answer only questions that are going to be graded manually. Don't give me any of this automatic stuff, manually only, right? So that pattern was, unanimously, nobody said, I want manually graded only. There were fractions here of students that are saying, well, actually both, this combination of both things works for us. And then there's a group here in which, or at least 2 groups in which more people are saying they would rather prefer just to submit questions where they're not showing their work. Now, as far as the other type of high-level assessments, which are the tests or exams, we have 2 types of exams, Telecom exams and Proctor exams. Now, Telecom exams are exams from some of these question banks. I had mentioned that the automatically graded questions, we were setting them up with a limited number of submissions. It was not unlimited, it was limited. Well, we use the same type of website for that question bank, but when it is a take-home exam, they only have, is very limited. They only have 1 submission because it's a take-home exam. Now, the difference is that when the exam opens, they have 48 to 72 hours to answer the exam. They know when you submit an answer, it's just 1 submission. So they could look at the question for a good 48 hours, work out in detail, and once they're sure, they can go and submit the answers for the questions that are going to be graded automatically. However, some of those questions in the take-home exam are going to be graded manually. In the same spirit of what they're doing with these portfolio exercises every week, so what we're doing is using the question bank to generate a randomized version of that question, and then each student is going to go and write on paper, scan the handwritten word, and then submit their handwritten answer to that question. You have a question? Yes.
What is to prevent them from simply taking the question and typing it into Wolfram Alpha and typing the answer out?
Yeah, Wolfram Alpha is, for those of you that are not familiar, Wolfram Alpha is like a artificial intelligence, you would say, website or something like that. There are online calculators like Wolfram for linear algebra that would compute reduced rational form matrices and would give step-by-step, like the raw operations. And Wolfram, I think with subscription, would give you also step-by-step. So, true, there are limitations with the take-home examinations, even when you're collecting answers from the students that you're grading manually. But these are groups of students that you're also grading manually every week. So you can start seeing certain patterns there. The important thing is that there is a balance. I admit there are some limitations, but there is a balance between Proctor exams and take-home exams. So the Proctor exams are proctored at professional testing centers. They are also exams that have short answer questions typically graded automatically and free answer questions that are graded manually. The questions are displayed in a computer. The short answer, short answer could be matching, multiple choice, sometimes literally short answer, just write a number, write a phrase there. But then the computer is displaying certain questions that are free answer questions in the same spirit as the portfolio exercises. Those questions are answered in an examination book or blue book, a little booklet where they write by hand. Calculators are not allowed in the Proctor examination. So the take-home exams have maybe the weakness that, well, there could be extra help. You mentioned, Rick, that what if they have a computer with artificial intelligence doing the exam for them? Well, it could be their cousin or the little brother, their big sister or somebody. It could be a human too. The other form of intelligence is not artificial. This is like organic, right? But there is a combination. There is a balance. They have to pass the take-home exams. They have to also pass the Proctor exams. So here's a sample on the bottom. There are two questions. They're really small here for you to see, but on the left you have a matching question. On the right you have a multiple choice, and then in the middle and the bottom, in the middle there is a word problem. In the bottom there is a question with part A and part B. Those are free answer questions, and this is kind of what this is how they answer. They use one of these so-called blue books, and even though they're in front of a computer reading the question, they start writing by hand on paper, on this pencil and paper, on this booklet. What I'm sharing with you here is what the students' answers was, and then the type of notes that I would write, a lot of errors and notes about steps that were missing or things that, they were supposed to do or things of that sort. So this was a way that we found in which we could basically integrate one of the best practices of traditional instruction with distance learning instruction, in which we could provide feedback to the online student exactly in the same way we would provide feedback to an on-ground or in-person student. So as far as the balance between take-home and Proctor exams, three options here, and this should not be a surprise. The last option, you look at every single thing that are rectangles. The last thing doesn't have a rectangle here, and it's because that is more Proctor exams are needed. That's the last option. We want more Proctor exams. No, unanimously, nobody is saying that more Proctor exams are needed. In the middle, there is an option of more take-home exams are needed, and the top answer was we had the right balance between Proctor exams and take-home exams. Now, I know you have a question, but let me try to go a little farther, and then I'll come back to your question. As far as the previous thing was about the balance between Proctor exams and Telecom Exams, this is a question about, well, what about the examination books, these blue books, okay? How useful were these blue books during a Proctor exam? So 5 options, from extremely to not at all useful. These are the students from Calculus 2. All of them are saying at least this is somewhat useful. Linear algebra, there's a fraction, small fraction there of people that were not so thrilled about the examination books, but sizable, most students here are saying very useful, extremely useful. Differential equations, at least somewhat useful, extremely useful. Most of the sample was pointing that, and there is a small, small number of people that were not that thrilled about using the blue books in their exams. And so I want to share this with you, which is an illustration of the geographical locations of distance learning students I had during fall of 2017, spring of 2018, and summer of 2018. And here in summer, I'm including students in the 3 classes, the Calc 2, linear algebra, and differential equations. These are locations where the students were located at the beginning of the term. Not everybody was proctored from this location, but it gives a sense, it gives an idea that relates to having the ability to proctor exams simultaneously from multiple locations, from different cities or across state lines, and doing it in a way in which you're integrating the technology with a computer. So when you're using a computer, it's because you created a bank of questions. And I think I learned how to do it the most difficult way, which is create the questions electronically, very similar to typing in Microsoft Word or typing in LaTeX. But then it turns out some testing centers are only proctoring paper exams. Some testing centers proctor paper and computer exams. And our testing center is particular in the sense that they only proctor computer exams. So, however, our testing center was, the director of that testing center was the person that gave me the idea of, he said, Ariel, if you write the questions electronically, so they are displayed in D2L, and your students use a blue book, we will collect the blue book for you. So they were the ones that came up with the idea to compromise, okay, the exam is electronic, and there is the lockdown browser and some IP restrictions and all sorts of things, but then the answers are provided by hand, and nothing leaves the testing center. They keep that blue book with them, okay? So, reports of online activity. I think this is also very useful. I am learning as an instructor. The first time I sent out these reports, the tone was not the most constructive tone. I probably sounded like Big Brother or federal police or something like that, Now I am approaching this with a very different tone. I want to make sure the students understand that these type of metrics are actually a tool for them they should exploit to help themselves in keeping track that, they are current and they are complying with all the tasks of a given week. The convenience of producing one such report here is a list of items. At the top, there is like a PDF. This would tell you if they're spending time reading the PDF or if they downloaded that file. At the bottom, there are some videos. Remember I said read, watch, and practice. So this is definitely related to the watch part. This keeps track of the time. So there's one video where they spent 0 minutes, 43 seconds, and another video where they spent 2 minutes, 40 seconds. Okay, this is progress. You are taking steps on the right direction. However, each of those videos is at least 10 minutes long. So what I try to, the message I try to send right now is like, this is proof that you are making progress, but this is an incomplete task, okay? So, and I encourage them. What I do is I generate.
So does I have to hold this down?
Yeah, for the red light. But if not, I repeat the question.
Yeah. So where you're monitoring the length of time of the videos, are these videos on YouTube?
Yeah, so these reports of activity, they are in YouTube.
Okay.
And these reports of online activity are not totally accurate. There are certain discrepancies. For example, the student may be watching the videos from their iPad or from a different, thing. They may find the playlist in YouTube, And this is something that they would answer me back after. They say, oh, what I do is I just go and watch a playlist directly. I don't use the D2L, And so there are certain things that are reflected here that are not exactly accurate, but the red flags, which is what the point I want to make next. The red flags are, I think, the most important in the sense if there is somebody that's showing very little activity, this person needs to know immediately that a change of strategy, a change of tactics is needed. So, for example, this is another view of the type of online activity of the whole class. On the first column, there are the names. You don't see them, but the second column, you're supposed to see certain blue bars here. So there is one person here that has a rectangle, an extended bar over there. The larger that bar, that means the person has been browsing through everything, downloading, watching, reading, When there is a person here that doesn't have a bar, it looks more like a dot, that means very little activity. So when I take a closer look, for example, that person, let me go to the other example here. This person with a lot of participation, a lot of activity, I can look at the log of accessing the digital content of the class, and there is a list with dates of when were the days this person was accessing, and also a count of the periods of absence, how many absent periods. So this person is accessing every day and then has periods of being absent 0 days. The other person has access, according to the snapshot, 3 times, and then has periods of absence of 5 days, 6 days, 14 days. So when there is a scenario like this, especially the one at first here with the little dot, this is exactly something that needs to be addressed. The sooner the better, because that person either has need more tutoring or time management, or they need to change strategy. So what I try to do with these reports now, I give them one that I generated myself the first week. The second week, I tell them, I show them how do you go to D2L, click, click, click. Here you generate your own. So I ask them to produce one report, a self-report on the second week and send it to me. And from that point on, I encourage them, use this as a tool for always managing your time and the items that are pending, or you need to, sometimes I also use something called checklists. I try to also do that for linking calendars with the items that are due on Wednesday, Thursday, Friday, and Saturday. And those calendars are part of their D2L. So I try to send them like 3 different types of reminders. So I know we're getting here towards the end. And I'm an advocate for diversified course portfolios. The summer of 2018 was a case study. We had classes that had 3 different channels. Interestingly, linear algebra, for example, had on-ground and video streaming during the 5-week session, and the asynchronous online was running over the 10-week session. So of these 3 classes, there were always a 10-week session. There was always a 10-week session. One class, Calculus 2, had only 2 of these methods, and differential equations was kind of a special section. It was only offered with the asynchronous online. So one of the differences I think this diversified course portfolio makes, at least in the summer enrollment when looking at 7 consecutive summers, is that it offers students more options. And so here there was a surge in the enrollment in these 3 classes during summer of 2018, and in part, I think it has to do with how the students answered this question. The question was, which of the following options do you think are more suitable to students during the summer? So the 3 samples that were consulted here were students that were taking a 10-week class that was asynchronous online. The 5 possible answers here, and they were allowed to choose more than one, in part because they were not only answering about their own individual choice, not choice, what it was more suitable for them, but what was suitable for students. So the first one is, I read them to you. 5 options. The top one, basically the first 2 are going to be about 5-week sessions, and the latter 3 are going to be about 10-week sessions. The first one was meeting every day in person for a period of 5 weeks. Second one, meeting every day by video conference for a period of 5 weeks. Third option, meeting twice a week in person for 10 weeks. Next option, meeting twice a week by video conference for 10 weeks. And the last one, is having strongly encouraged but not required weekly meetings, either in person or by video conference, while using pre-recorded videos for a period of 10 weeks. So this is what the sample of Calculus 2 students was answering. These are the linear algebra students, and these are the differential equation students. So I think that here, this is more telling. I wouldn't say it's not so much about on-ground versus online. I think in the summer, what this is reflecting is more about 5 weeks with a very rigid schedule and 10 weeks with a more flexible schedule. And here you see the longer bar in the last option, I think in part because all these three populations were students that were doing exactly that, So I think that the rigid schedules are easily outcompete with full-time employment during the summer. And
Ariel, I'm sorry, can you go back to the previous slide, the line graph slide?
This one.
Right. So I'm trying to figure out what's going on with that, the shift from 2017 to 2018 on there. I mean, were there more sections? I understand they had more options in 2018, but were there more sections in 2018?
Usually in the summer prior to, so basically in 2017, between 2012 and 2017, there was only one section that was on ground during 5 weeks. It could be summer 1 or summer 2. In summer 2018, one class had 3 sections, one class had 2, and one class had only 1. The other thing that was different is I'm the principal investigator of National Science Foundation grant, and there were some students that had funding, they had scholarship money, and they populated some of these classes. So for example, there were, and this is where differential equations was like a special section. There were 8 out of 11 students in DFQ with funding. And linear algebra, there were 6 out of 26 with funding. And in Calculus 2, there were 4 out of 41. So the surges here, certainly there was an injection there of students with funding populating some classes. But if you compare 2018 to 2017, one thing this has been a struggle, bless you, you can see that in 2017, consistently, all these 3 classes had fewer students than they did during the summer of 2016. In fact, differential equations here appeared with 0 students because DFQ was canceled in 2017. The year prior, it had 4 students. Linear algebra had 10 students in 2017. It had 15 in 2016. And Calculus 2 had 20 students in 2017, and it had 30 students in 2016. So, I think there was certainly an effect of having students with scholarship funding, but I also think that the effect of diversified portfolios has more to do with the way they're answering these questions about rigid schedules versus more flexible schedules. So when you schedule a summer class over 10 or 12 weeks, the longest it could be is 12, because that would be pre-summer, summer 1, and summer 2 all put together. When you schedule a summer class over 12 weeks, now that's looking pretty much like a 15-week class in a regular semester, which means that there's no longer need to meet with students every day of the week if you're going over 12 or 10 weeks, unless you want to meet them for 30 minutes, 5 days a week, right? So you could schedule meetings twice a week for 2 or 3 hours, and I think that would open up their whatever competition there is between the school schedule and the work schedule. I think these 10-week or 12-week sessions could offer more flexibility,
So the spike that you're showing there in 2018, you're right, I was 2018. These were 5-week courses, or these were 15?
No, each point here is the aggregate count of the 5-week and the 10-week. So each point,
The 10-week weren't offered in some of the earlier sessions.
The 10-week were not offered in the previous years. That's right. So 2012 through 2017, it was 5-week on-ground only. And then in 2018, there were more options, 5-week on-ground versus 10-week online. But you could easily have...
And financial support.
So Rick is saying, and with financial support from the scholarship program, that's correct. I think...
And I'm just going to interject. So in the Calculus 2 course, it looks like 41 students. 41 students?
41 students,
And
yeah.
4, you're saying 4 were receiving.
4 had the financial support of the scholarship program.
Okay.
The other part of financial support that is complicated, possibly more complicated now than it was 10 or 20 years ago, these rules change all the time, this financial aid. So the usual financial aid rules would require a student to have 6 credit hours to then, at least 6 credit in the summer, to then have to be eligible for financial aid. So if you compound that with the rigid schedule and the full-time employment, and now, 6 credit hours means at least you have to take 2 of these classes in both sessions. So I think that's part of what explains some of those trends there. So, yeah, okay. I guess this is the end. I don't know if somebody that's in Webex would like to ask something. I can certainly stay here and address some of the questions with some of the people here, but Rick.
A very, very quick question.
Yeah.
I have one very quick question. Suppose a student were to make 100 on all of the tests and work that was not proctored and a 0 on all of the proctored work. Could they pass the course?
That would be specific to the syllabus. So that when in the summer I had like a draft of the syllabus that I had for the formal review, and each instructor, John and Michael, they made some changes. We kind of agreed on also the percentage distribution. So in my case, the way I have it, I don't think that would be possible. So that's the balance there. You could also, but I tell you, in the summer I had 3 plus 1, 3 tests, 1 final exam, so 4 examinations, and I think they were 2 and 2, like 2 proctor, 2 take home. In a regular semester, I have 4 plus 1. Previously, I think I had 4 plus 1 with 3 take home, 2 proctor. This semester, I'm doing 3, 4 plus 1, 5, 3 proctor, 2 take home. So you could also, and the way I do it is that I give equal weight, but you could also put more weight. You decide that you can put more weight on the proctor exams. So you could design it in a way in which you really need to prove that there is proficiency here and that this in a proctor control environment, where there's no calculators and things of that sort.
Do you find some students' grades on the proctored exams sharply decline?
Yes. So there is something about, the question was, do you find that when students are tested on the proctor exams, are the grades are good as they are when they are in the take-home exams? And there is a struggle there is a discrepancy, and that makes this type of online instruction similar to the on-ground instruction in that sense. So in the summer, we devise mathematics clinics. What would that be? Well, it's kind of like office hours or something, but the clinics were, at least the concept, we deploy them in different ways. I'm still working on those. The clinics would be aimed at meeting with students either by group or something where they bring that exam, and then you have a little conversation with them, give them a little guidance. Maybe you have an answer key, and then you devise a plan with them. Okay, I'm going to let you submit for recovery points, not for full credit, but for partial credit, to bring you up to speed, up to some level. That would be the idea of recovery, like maybe you were too bruised there. But more of them producing the correct steps, which would be the answer key to their question. And this is another idea from my collaborator. These recovery points work better when they have to explain, in view of the answer key and in view of what they write, when they have to explain why they miss or why they missed. And that sometimes takes them on a route that is quite different and very interesting and allows them that true recovery process, and it promotes engagement. But going back to your point, Proctor exams versus take-home exams, yeah, Proctor exams are more difficult. The performance in Proctor exams is not as it is in take-home exams. I used to do take-home exams that were all automatically graded. So then the grades were even more inflated, And now that I have take-home exams where they have to show where there are selected questions that are manually graded, and the point distribution for the manually graded question, I give you an example. Maybe there are a total of 10 questions. 3 are manually graded. So I say these 3 questions are 10 points each, that's 30, and each of the other 7 questions is 1 point each. So a total of 37 points, 1 point for the automatically graded, 10 points for this manually graded. So that creates, a distribution of effort. And so that's what I'm doing this semester, and I see the grade distribution of that take-home exam doesn't look as inflated as it did in the past when everything was automatically graded. So I think I should probably disconnect, and I'll be happy, Rick, to share my syllabus with you and talk a little more. And I thank you all for attending.